Hi, everybody. This is Dr. Nigro. These are your notes that we're going to use for the first part of our new unit, which is on motion. You should have your note sheet with you. You're going to see that I have put pieces of the note sheet into this presentation, and I'll be filling that out with you. But in addition, I've got just some pictures that we'll talk through. All right. So this new unit looks at motion, and we should start that with a definition of what is motion. So a motion is considered any time that an object changes its position relative to some sort of reference point. All right, so if you have an object that was sitting still and then all of a sudden is moving, we would say that object is in motion. When we describe this motion, we want to know several pieces of information. We'd like to know how far the object has moved. We generally want to know how fast that object has been moving. We want to know how long it's been in motion, and we'd like to know the direction that object is moved. So when we have something in motion, again, these are just a couple of the questions that we like to answer. All right. So we're going to start with how fast, which deals with speed. So speed is a measure of how quickly an object can move over a set distance. All right, the formula is here. So we have distance over time. So this is a rate of motion. So how much distance gets covered over a certain amount of time? And we're going to look at this formula a little bit closer on the note sheet. All right, this equation gives us the average speed of an object over a set interval of time. All right. Now, when you're in your car, you can actually change your speed by either using your gas pedal or your brake, and we read that speed on our speedometer. For some people, it's a dial like shown here. All right. But in some of the newer cars, you may actually have a digital readout that tells you your miles per hour. All right. When you look at that speedometer, it tells you the speed at that exact instant at which you look at the speedometer, and that can change depending on whether you're speeding up or slowing down. But that one instant is the instantaneous speed. All right, so let's list out some of this information. Let's start with what is motion. All right, so motion occurs when an object changes its direction or its position. Let's say position, I think that's a better word here. Position relative to a reference point. All right. And that word, that term, phrase, reference point, it's just a fancy way of saying if it's changed its position from where it was to start with. That's all. All right. So how do we describe this motion? We ask a couple different questions. We'd like to know how far an object has moved. We'd like to know how fast that object is moving. We often like to know what direction the object is moving in and how long it has been in motion. All right, you're going to see these terms at the beginning of most of our questions. All right, now what do these terms mean in terms of our variables? How far is a measurement of distance traveled? How fast is going to be the speed of that object? What direction? We're going to use directional pieces like north, south, east, west, left, right, forward, backwards. And then how long is a measurement of the time that object has been in motion. All right, so when we describe how fast an object is moving, we are describing that object's speed. All right, speed, as we saw on the previous slide, is equal to the distance the object travels divided by the time it takes you to travel that distance. If we use our variable symbols, S is equal to D divided by T. This is the rate of motion. All right. For our formula triangle, which is always handy when we're trying to figure out our different formulas, we have distance, speed, and time. So distance divided by speed is going to be equal to time. All right, distance divided by time is going to be equal to speed, and then speed times time will be equal to our distance. All right, I should pause for just a minute and talk a little bit about the units you should expect here. Speed will have units of meters per second. distance should have units of meters, and time should have units of seconds. All right. So when you're trying to work a problem, you define your variables by using these units. All right. So again, speed is meters per second, distance is meters, and time is in seconds. Okay. So let's try a couple practice problems. All right. Then we'll continue on with our discussion of motion. All right. So we have for problem number 1, we have during your trip, you cover 805 meters of distance in 3.5 minutes or 210 seconds. What was your speed in meters per second? All right, so if we look at what we've got, we have a distance value of 805 meters, and the time that this motion is occurring in is 210 seconds. Now, it's important that we use seconds here because the problem asks for that answer in units of meters per second. All right, so if you look back at your formula triangle, you'll see that the speed of the object is equal to the distance divided by time. So 805 meters divided by 210 seconds is going to give us a speed of 3.8 meters per second. All right, so now let's look down at number 2. All right, later in the afternoon, you travel to a restaurant. How long does your trip take if you travel 3,800 meters at a speed of 15.6 meters per second? So this time we've got a distance of 3,800 meters and a speed of 15.6 meters per second. The question's asking how long, which is time, so that's going to be our unknown, and we'll get units of seconds. So if we go back to our formula triangle, we'll see that time is equal to distance divided by the speed. All right, so 3,800 meters divided by 15.6 meters per second is going to be equal to 244 seconds. So that's how long the object is going to be in motion. All right, now obviously we could also solve for distance, and then we would have speed times time, but I don't have an example for one of those. All right, so now how can speed be described? Well, there's really 3 ways we look at speed. We can talk about constant speed, we can talk about average speed, and we can talk about instantaneous speed. All right, now let's start with constant speed. If you say that the speed of an object is constant, then that tells me that the speed does not change throughout your trip. Through the trip. All right, this happens most often to you if you're driving on a highway. All right, you tend to put on the cruise control or you go about the same speed the entire time. All right, and that would be an example of when you might be using constant speed. All right, average speed is just exactly what it sounds like. The average speed during a trip. All right, now to calculate the average speed, we need a special formula. We use the S symbol again. We put a little line over it, or we write average down here. And that's equal to the total distance that you travel divided by the total time of that travel. All right. Now, the last one is instantaneous speed. All right. And that is your speed at a particular point during your trip. All right. This is really when you look at your speedometer. All right, and you notice that, let's say you glance down and you're going 65 miles per hour. All right, that would be an example of an instantaneous speed. It's only good for that one time point where you look down at that speedometer. At any other time, you may look down and be going 75 miles per hour or 55 miles per hour. All right, so constant, average, and instantaneous speeds are terms that are going to pop up throughout our unit when we talk about what type of motion an object is undergoing. All right, so having an idea of what those 3 terms mean is going to be good. All right, now let's talk a little bit about the difference between instantaneous and average. So here we have an example. We have a car, and that's driving to school from home. And as part of that trip, they go through several stoplights and a stop sign or two. All right, the travel is a total of 5 miles, and it takes about zero point 0.2 hours to make the trip. All right, so the first question is, what is your average speed? So throughout the trip from time 0 to 5 miles, from distance 0 to 5 miles, what is the average speed at which you drive? All right, so that average speed is equal to the total distance that you cover divided by the total time it takes you to cover it. And for this trip, it's 5 miles covered in zero point 0.2 hours. So that means that we have an average speed of 25 miles per hour. Now, the question is this the same as your instantaneous speed? All right, why or why not? So this is an average speed, right? So instantaneous speed could be anything between 0 and 25 or even above 25 miles per hour. So no, this is not your instantaneous speed, all right, because that is at a single point. So instantaneous speed is at a particular time point. All right, so in other words, if I'm looking up at my figure, I might be going, maybe let's say this is a green light, so I could be going 25 miles per hour here, but then here comes a stop sign, so I may slow down to 0 miles per hour. And at any point during this portion of the trip, if I look down at my speedometer, my speed could be anything. All right, so I just need to keep in mind that average does not affect instantaneous speed. All right, the next question is the car driving at a constant speed? Well, if you look at the trip, we've got stoplights, stop signs, and so we've got to be speeding up and slowing down throughout the trip. So we can't have a constant speed because that would tell me it was the same value throughout the trip. So the answer here is also no. All right, we're going to slow down and speed up throughout trip, which means our speed is changing. All right, so we're going to have changing speed. All right. All right, so that's all we're going to do for today for this video. All right, I'll have another note sheet that's going to start with our vectors versus scalar measurements. All right, so go back, make sure that you filled in all of your note sheet for speed and motion, and then come back and you can work on your vector and scalar measurements.